let's just see the very first topic of this particular chapter, in which we are going to discuss about the figures on the same base and between the same parallels. What does it mean? Let us suppose if I'm just talking about this figure. So in this figure, you can see that we have the two figures that are lying on the same base. So first of all, we have a trapezium, which is A, B, C, D, and then we have a parallelogram, which is E, F, C, D. So as you can see, this trapezium and this parallelogram, they are actually lying on the same base, which is nothing but DC. So isn't it interesting that the two figures are actually lying on the same base? Now furthermore, if I'm just talking about the other figure, so as you can see, we have the two parallelograms again over here. We have PQRS, we have MNRS. Both are again lying on the same base, which is nothing but SR. Furthermore, if I'm just talking about this figure, you can see over here that we have the two triangles, which is nothing but ABC, and we have DBC. Again, both of them are lying on the same base over here. Furthermore, if I'm just talking about this particular kind of a figure, in which we can see we have a parallelogram, which is ABCD. We have a triangle, which is a PDC. Again, both of them are lying on the same base, which is nothing but DC. So you can easily find out the base on which both of the figures are actually lying if I'll ask you to find the base or the common base on which both of the figures are lying. So it is quite an easy thing to find out the common base of all these figures. But now let us suppose if I'm just taking the figure of such kind. So can you just create a differentiation in between the previous figures and this one? So you can see over here that again we have the two figures over here, which is nothing but a trapezium and a parallelogram. ABCD is a trapezium and EFCD is nothing but a parallelogram. Now what is the difference in between this figure and the figure that we already have done in the previous particular example? So the difference in between both of these is that they do have the same base, but now as you can see, all these vertices of these two figures are actually lying on the same straight line. They are lying on the same straight line. So what can we say? We can say that these two figures are actually lying on the same base and they are between the same parallels. What are those parallels? One is AF, which is nothing but parallel to DC. Furthermore, we can say that if we are just talking about this particular figure, we can say that these two figures are actually lying on the same base, and the vertices that are opposite to this particular side are actually lying on the same straight line. We can also say this thing, which is similar with this particular figure. Now furthermore, if I'm just talking about the second kind of a figure, so you can see over here again that we have over here a trapezium and a parallelogram, or we have the two figures again, whatever be the two figures. So we have the two figures again. So as you can see over here that the two figures are now again, they are lying on the same base and they are between the same parallels, because all these vertices that are opposite to the SR common base, they are lying on the same straight line. Now furthermore, if I'm just talking about these two triangles again, you can see that these two triangles are lying on the same base, which is BC, and the vertices that are opposite to the common base BC are lying on a same straight line, which is nothing but AD. Furthermore, we can say that this figure, in which we have first of all a parallelogram, we have a triangle, they are again lying on the same base DC, and they are they are lying in between the same parallels, or we can say that the vertices that are opposite to the common base are actually lying on a same straight line. So if I just want to conclude the statement which is related with all these figures, then I can say that the two figures are said to be on the same base and between the same parallels if they have a common base. If they have a common base, that is nothing but a side, and the vertices or the vertex which is opposite to the common base of each figure lie on the line which is parallel to the base. So you can see all by yourself that this particular definition or this statement is actually true for all these four figures. So first of all, if I'm just talking about the very first figure, so in the very first figure you can see that the base is nothing but DC, the two parallels are nothing but AF and DC. Furthermore, as per this particular condition, it says that the vertices, and you can see in the fourth line, that the vertices opposite to the common base of each figure lie on the line which is parallel to the base. So as you can see over here, these vertices are actually lying on a line which is parallel to this particular base, which is nothing but DC. And this is true in this figure as well, this is true in this figure as well, and this is true in this figure as well. So this is all about the figures that are lying on the same base and between the same parallel. So always remember this particular condition which is related with the figures that are on the same base and between the same parallel, that they do satisfy such a condition if they have a common base and the vertices opposite to the common base of each figure lie on the line which is parallel to the base. Now let us suppose if I'll ask you a question, that whether this figure is nothing but the figure which is lying on the same base and between the same parallel. So first of all, let us suppose if we are just checking it, we have the two triangle over here. First of all, we have AQR, and then we have a second triangle which is nothing but DQR. So as you can see, this figure do have a common base. This figure do have a common base which is nothing but QR, but is it lie between the same parallels? So the answer is quite obvious. We can see that this particular vertex D is actually not lying on this particular line L. So it means that they are not lying in between the same parallels. They do have the same base, but they are not lying in between the same parallels. So what can we conclude for this particular figure? We can conclude that this figure, or in this figure we have the two triangles which is AQR and DQR. They are on the same base but not in between the same parallels. We can see this all by ourselves. Now again, first of all, if I'm just talking about this particular figure, or if I'm just talking about this particular figure, again we can say with the same concept that this figure and this figure, they are lying on the same base but they are not in between the same parallels. Because if I'm just talking about this, if I'm just talking about this, the vertices that are opposite to the common base, they are not lying on the same parallel line or on the parallel line which is to the base. So this figure and this figure, or this figure if I'm just talking about, they are lying on the same base but they are not in between the same parallels. And furthermore, here we can conclude that out of the two parallels, one must be the line containing the common base. So this is quite an obvious result, as we can see, because out of the two parallel lines, one is always the line which is nothing but containing the common base, and other is the one that do have the vertices which are opposite to the common base, and the vertices always lie on that particular parallel line. Now let us suppose again, if I'm just asking you that whether this particular figure is lying on the same base and between the same parallel. So first of all, we can see over here that they do not have a common base. Why so? Because these two triangles have a different base. The one triangle that we have, that is nothing but DBE, do have a base as BE. But if I'm talking about the triangle which is nothing but ABC, then it has a base BC. But they are lying between the same parallels. Why so? Because the vertices that we have which is opposite to the base is actually lying on a same straight line which is parallel to the base. So it means that we can say what we can say for this particular figure, that this figure is actually not on the same base but between the same parallels. It is not on the same base but between the same parallels, and the same condition we can say for the second figure. So as you can see over here, again we have a triangle, we have a parallelogram, and their bases are definitely not equal to each other. You can see all by yourself that the base of the triangle is nothing but CB, but the base of the parallelogram is nothing but PS. So they do have the different bases, but they are lying between the same parallels. You can see that these two are the parallels. They are lying between the same parallels, but their bases are not the same at all. So this is all about the concept of the figures that are lying on the same base and between the same parallels. I hope you can able to differentiate in between the figures that are lying on the same base and between the same parallels, or the figures that are lying on the same base only but they are not in between the same parallels, and many more such other conditions. So this is all about the figures on the same base and between the same parallels.